Hello everyone, and welcome back. In this week's installment of our tutorial series, we're going to continue to ease into talking about working with P5.js and data, and our theme is going to be data streams. So we're going to talk about, taking numerical data, representing it graphically, and also some basic operations we can do on this data that comes in. In the first lesson, we're basically going to be building a simple graph, and that's going to help also serve as a way to help refresh some concepts. We're going to be using the mouse coordinates as our data source for these examples, just because it's there and readily available, but you can imagine substituting any kind of data for the purpose, and we'll be doing that down the road. And then in the second example, we'll build on that graph program that we're going to write, and we'll add a little bit of data manipulation. So finding the boundaries of a data stream, and also finding adding some smoothing and some averaging to that data stream. So let's jump into it in this first example here. So the first thing we're going to do is, just with every other demo we're going to be doing this semester, is we're going to start with our blank template on Glitch. And we are going to remix it. That's going to be our way of creating a new sketch. So I'm going to remix the blank template here, just so I get a new project. And this is really just the most convenient way for us to do this on Glitch. In other editors, like the P5 built-in editor, you might just create a new sketch, but because Glitch is not specific to P5, remixing a default blank template just kind of bootstraps us into having a functional program. And let me make this text size a little bit bigger as well. Okay, so for our first lesson, like I said, we're going to be building a graph. This is going to be sort of elaborating on what we did last week. And in this week's set of lessons, we're keeping things fairly basic as well, because this is an opportunity for us to review a lot of concepts and refresh ourselves on some ideas. So in this case, we are not going to be using any particular kind of data. So just to keep things simple, think of, data here could be any changing number, right? Any kind of number stream coming in. So that could be, the mouse is a sensor, right? Or your trackpad on your device, or the touch on a screen. So we're going to be using the mouse cursor as a way of providing us easy changing data that we can work with. But you could easily substitute that with, something like maybe a distance sensor that's measuring the position of, someone in relationship to an object. Or perhaps, a capacitive sensor, a light sensor, whatever other numerical source you might be working with. And this idea of the graph, it's going to allow us to explore some basic ideas and refresh some concepts. Okay, so in order to build a graph, what we're going to do is we need a place to store the data that's coming in. If we look at the mouse X coordinate, for example, it's a changing number, but what we want to do here is record its values for a certain amount of time, so that we can show how it's been changing over time. So the best sort of structure we can use for that is an array. And this is how we define arrays in JavaScript. We're going to say let values equal square brackets. We're also going to define a variable here. I'm going to call this max values. And this is going to be the number of data points we're going to be recording. It's also essentially going to become the size of our array. So in this first iteration here, we're going to build the graph. And then later on in this video, we're going to talk about how we could better structure this graph program to make it more reusable. So let's set a black background here and a white stroke for this example, just because it's a little bit less jarring. And first is we're going to record some data. And here we're going to use the mouse cursor because we have access to it. And but you can imagine if any other sort of number coming in here could be substituted in its place. So in order to record the data, we're going to take the mouse cursor values in every frame, and then as we read them, we're going to add them to the end of our values array. And the way we do this in JavaScript is we use the push function of the array object. That's going to take the value, add it to the end of the array. So I'm going to push mouse X onto values. And then if I keep doing this, this array is going to get larger and larger. So we'll get to that in a second. But for now, let's write a little loop here that's going to iterate through all the values we've recorded. So we're going to use a for loop. So if you remember, the first ingredient, right, of a for loop is a counter. So I'm defining a variable called I here equal to 0. The middle portion of the for loop defines the loop condition. So we'll say as long as I is smaller than values.length, which is the number of elements contained inside the array values, we're going to increase I by 1. And then I open and close the curly brackets to define the body of the loop. This is the portion of the code that we're going to repeat. And as we do this, we are going to say, okay, let's take well, actually, let's not do anything just yet with the loop. Now, if or we could do just something simple, like let's just to make sure that it works. Let's draw a circle at values bracket I. So that's going to be the current value, and then height over 2 for the height. Okay, so we can see we're recording some kind of X value here, but that's not super useful. That just told us that our array is working. Now, if we keep adding values to this array values, if we keep pushing data to the end, this array is going to grow and grow and grow into the thousands and tens of thousands and so forth. What we want to do here is just record kind of a recent snapshot of the data so we can draw it as a graph. And that's why I declared this variable up here called max values. This is on the number of values we want to be holding at one time. So we are going to use a conditional here. Remember, conditionals are if statements. They allow us to ask a question about what's going on inside our code. We'll say if values.length ever gets larger than max values, so if we have too many, what we're going to do is we're going to remove the oldest value in our array. So what's the oldest value? Well, it is the value at index 0. So if you think about it, if you keep adding elements to the end of something, right, their index is going to, the indices are going to increase in the array, and the very first thing you added is whatever you can find at index 0. So if we take that out, and we're going to use the splice function of the array object to do that. So splice takes two parameters. The first one is where do you want to cut? What's the index where you want to make a cut? That's going to be index 0. And then it's asking us how many elements do we want to remove? We'll just remove one, but you could actually remove multiple elements at a time. So here 0 is the index of where we want to cut, and 1 is the number of elements to remove. So you can see now that we're only seeing 100 values, right? This is getting, array is getting deleted, and it's basically kind of just creating a trail right now behind my mouse cursor. Yep. So very similar to what we did in last week's video. So now that we have this basic structure in place, right, we have an array called values that's recording the mouse X coordinates coming in, and it's always keeping the most 100 most recent values. We're going to turn our attention to the for loop here to sort of interpret how do we choose to interpret this data or this history of numbers. So to keep things simple, we're going to just simply plot it as a graph made out of lines. Okay? So I'm going to get rid of this circle here. So we're going to draw a series of vertical lines, right? And the height of that line is going to represent the mouse X coordinate that we recorded, or the number that we recorded in our data stream. In this case, it's going to be coming from mouse X, but remember, this could be any stream of numbers. It could be coming from a sensor or whatever. It doesn't really matter. We're using the mouse here for simplicity because we have it and we don't have to worry about finding a number source for this example. Okay, so how do we go from this history of numbers, right, to some kind of visual representation? Well, we're going to have to come up with some sort of mapping between the values in the array and how we want to present them visually. For example, we could decide that we're going to represent them success successively from left to right. So the first value in the array is going to be on the left, and the last value in the array is going to be on the right of my screen, and everything in between is going to be the remaining values in the middle. So we might decide that the x coordinate, for whatever we're about to draw, we're going to spread the values out from left to right on the screen. So the variable I here, which is our loop counter, that's something we can use to achieve that, right? So we know that when I is 0, we're reading index 0, which is the beginning of our array, we're over here. And then when I is 99, we're reading close to the end of our array, we want to be over here. So we're going to use map to make this calculation a little bit easier. I'll be really emphasizing map in this lesson because as we'll be working with data throughout the semester, map is a really useful tool to really get comfortable with. What map does is it says, take a number, let's say the number contained inside the counter I, so this is your input, and then given a little bit of information, map is going to either shrink or stretch that number to fit whatever range that you need it to have in order to suit your purposes. So the first parameters, once you decided, okay, I want to map I, the first pair of values we're going to provide is going to be what is the range of I in our program, right? What is its minimum and maximum? Well, in this case, it goes from 0, right, to values.length. Values.length minus 1, technically, because the last value in an array, right, is because we start counting from 0, right? The last value is going to be index 99. So this tells the map function what are the boundaries of I. And this idea of boundaries in data is going to be an important concept, one that we're also going to explore in the next video this week. You want to kind of have a sense when you're working with numbers, what are the minimum and maximum values, so you know what boundaries you're within, so that you can do things like map the number, for example, to some other range. So here we could say, let's take the counter, right, which goes 0 to 99. Let's map this to some x coordinate from left to right in our window. So this could be mapped between 0 and width, for instance. And then we could use this now as an x coordinate. Just for now, let's throw in the mouseX value, just whatever is the raw data inside our array, and put in a size for our circle, just so we see that it works. So we can see now, this is our graph happening over time. So we're drawing the last 100 mouseX values. Now, depending on the size of your window, right, just using mouseX directly may not be the best fit for the space that we have available. So let's be a little bit more intentional on how we represent this value. Also, I don't really want to draw it as circles. In this example, I'd like to draw a bunch of vertical lines just because I feel like it. So we're also going to map the data value we recorded into a range that's going to be suitable for display. So a range that's going to go from 0 to height in this case. Because yes, it so happens in this little demo, the data is a mouse coordinate, so it kind of fits within the screen here, but you can imagine this could be any stream of numbers, in which case the values might not be suitable for coordinates, right? You might get numbers from a sensor that are just these huge numbers, right? Or that may have nothing to do with a position at all. So let's calculate a y value here that we want to represent as well. And this time we are going to map, let me comment this out, we are going to map values bracket I. So this is the actual data point that I have in my array. So now we're going to say, okay, so what's the minimum and maximum for this data point? Well, that's really going to depend on the data. We'll talk more about that in the next video, but for this example, we know that the data goes between 0 and width because we're using the mouse coordinate, right? Where is it? We're using the mouse coordinate as our source of data points. And then we're going to map this to a range that goes from 0 to height. Okay. And then now we can use that information to draw some lines. Okay, so instead of a circle, let's draw a line. So a line in P5 is 2 points. Okay, so the first point is going to be x, and let's say x and our data point at y. That's going to be one end of the line, and then the other end of the line, we're always going to anchor it on the bottom of the screen. So that's going to be x again, and then height. All right, so now we get this effect. Now you might notice when I'm on the left side here, right, the way I chose to do my mapping, if I have a low x value, right, if I have a small number, I also get a small number out of this. But for my purposes, for the lines, this is actually giving me the opposite of what I really want to represent, right? I want a short line when x equals 0, and I'd like to see a tall line when the value here is bigger, right? The value of my mouse cursor is bigger. So what I need to do is kind of revert how I'm mapping these coordinates, okay? So that small values of small numbers inside values will correspond to high numbers on the y-axis, right? And that's just because the way that the coordinate system works in P5.js, 0, 0 is in the top left corner, right? And the y values go increasingly as we get increased towards the bottom. So that's very easy to do with map, because you can decide here. Here I'm choosing to map from 0 to height. If I want to reverse the relationship, I can just reverse the boundaries of map. I can say instead, why don't we map from height to 0 instead? So map is very flexible in that way, and it's going to be kind of our primary number manipulation tool, and we'll build on that in future lessons, but you can get really far just by relying on map to do all sorts of number manipulation tricks. Cool. All right. So now we've created basically like a simple graph. It's a real-time graph, so we're adding data to it in real time. Of course, it's pretty boring data right now. It's just the mouse cursor, but bear with me. It just gives us a number to work with. And then we are dynamically kind of removing old values from the array as it gets bigger and as we're adding more to the end. So we only ever keep the last 100 values. And then we have a little bit of code here that's taking, okay, well, let's take this history, which is the array values, and let's represent it visually. And here we're using a very simple visual representation, which is just a series of horizontal lines that kind of evoke a graph of some sort. Okay? But you can imagine all sorts of different ways we could represent this history of numbers, right? It's just a number sequence, and we could translate that to really literally whatever we wanted. Okay. So that's a pretty basic, straightforward example, but we're going to use this week as a starting point to talk about, to refresh some maybe more advanced ideas. So the next thing we're going to do is we're going to talk about representing this idea of our little data graph here as an object, as a class of objects, so that we could create lots of graphs, for example. Maybe you want to chart different values at once. We'll kind of encapsulate that into an object, and we'll use that as an excuse to review that syntax. And then in the next video, we'll talk about some basic manipulation we can do on this data stream, right? How can we calculate some information like the minimum maximum, and how we might do some manipulation like filtering or smoothing. So that's going to be for the next lesson right after this one. So first, let's talk about how we would represent this graph here as an object. Okay? Now, why might we want to do this? Well, let's say I wanted to add a second graph to this program. Maybe I want to make it a little bit smaller so it's not taking up the whole screen. And next to it, I would like to see some other piece of data, some other data history, maybe mouseY in this case, because I have two values, or again, it could be whatever. So rather than have to do all this work twice, we can think about, okay, well, what are the things that define a graph in our program? Could we write a template of sorts, or a class, that we could then use to instantiate a graph object? And a graph object would contain both the information, the data, the variables that are associated with this graph, so things like the number of the values that it contains, the maximum number of values, and then any other properties we might want to put onto this graph. As we develop it, we'll have other properties we're going to add. And alongside with this data, we're also going to put the code that relates to adding data to the graph, right? Keeping it the correct size, drawing the values. We can put all of that code into one place called a class, and then we can create instances of that class. We'll be able to create copies of our graph idea, and we only need to program it once to create multiple graphs. So let's refresh this concept, because that's a really useful and powerful idea when we're programming. Now that we've kind of sketched an idea like this, we can now talk about like how would we properly structure this so that it allows us to build more interesting programs out of this. Okay, so the syntax to do this in JavaScript and incidentally in P5 as well. There's many different ways to create objects and classes in JavaScript, but for the purposes of this series, we're going to stick with the class syntax. Okay? Because it most closely resembles the way we would create classes in an environment like Java and processing. Yeah, so just keep in mind, there's other ways that we can create and structure objects. We'll just use that one for our lessons here. So let's define a class for our graph. So the syntax for creating a class, we use the keyword class, we give it a name, and you'll notice I always pick a capital letter to name my classes. That's not a requirement. Okay, it could be a lowercase letter. That's more of a standard practice. If you define classes as uppercase, then that's going to remind you that the name of the class is in uppercase, right? That refers to the template, whereas you'll see when we create an instance or a variable, that's going to be named in lowercase. So it gives us some visual cues to remember what's what as we program. So our class is defined like this, and it has a start and an end, right? Just a lot of it's a kind of another type of code block, just like we have a function here, right? And we have the body of a for loop. So it's like a code subsection. So it starts with the curly bracket and ends with the curly bracket. And then within it, it's going to have one section that's we're always going to have in there called the constructor. So that section, we don't get to choose its name. We just call it constructor. So this code runs when we create an instance of the class. So when we're going to make a new object from the class, the constructor is going to be called. And then after that, we'll be able to put any number of other functions we want to include. Okay, and we'll define those as we go along. All right. So we said the job of the constructor, right, is going to be to create the newly minted objects from our class. So oftentimes constructors are going to have parameters that are going to allow us to provide some values when we first create an object from a particular class. So in this case, if we imagine, our graph idea here, maybe for the version where we write a class for it, it would be nice if we could specify a size for the graph. So it's not always just taking up all of the window. So maybe we'll provide attributes of the graph, things like an X and a Y coordinate for its top left corner, maybe a particular width and height. So the way that we could do this is through some parameters. So we could say, okay, this graph is going to have an X and a Y value, and maybe a width and a height. So I'm just going to be lazy here and use W and H for width and height. And those values will have to be provided when we create a new graph. And what the constructor's job is, a lot of the times, is to say, okay, take the values that the program is going to provide as parameters and save them inside internal variables to the graph. And the syntax to do that is using the this keyword. Okay, so this is kind of it's an introspective keyword. It refers to the object itself, this. So we could say this.x equals x, this.y equals y, this.w equals w, and this.h equals h. So the idea here is that the constructor is going to receive a series of parameters, right? It's going to take those parameters, which have the same name here, but these are different variables, right? This is going to refer to an internal variable of the graph object. So this becomes a property or an attribute because it has the this keyword in front of it. We're making it equal to whatever is being provided through the parameters. So that, for example, we could write then a function that's going to use these 4 values we saved to do something, like draw a shape or something like that. So I always like to not get too far ahead of myself when I'm programming and just kind of test things as we go. So even though we won't have the full graph yet, let's just take some of the code we have over here and we're going to comment it out. Okay, so I just did a control / here, allows me to block comment codes, or I can also block uncomment them. That's pretty useful. So let's comment this out so we can just get rid of what's happening over here. And we are going to go ahead and create an instance of our graph class. Okay. So we're going to call this one graph lowercase. Okay. Or I could just call it G or whatever. Okay. And that's going to be defined over here. So I'm going to declare the variable and I'm going to create it in setup. Okay. Just in case I need to refer to maybe the window width or the window height, things like that. So we'll say graph equals new graph. So this is how we instantiate objects from a template. So now that I have this graph class and a constructor, I can create graph objects. Granted, they don't do much yet, but we'll get there. But I like to kind of scaffold things as I go so that I don't write too much code without having something working over here. It makes it difficult when you make a mistake to backtrack and find your way back. So here in the constructor, we said a graph will have 4 parameters we're going to provide. So this graph here is going to need 4 values, an x, a y, a width, and a height. Okay, so let's just give it like just whatever for now. Let's say 200, 200, and then it's going to be 100 by 100 pixels. Okay. That's going to be, actually, let's make it bigger, 300 by 300. That's going to become the size of our little graph. Okay. So these values, right, are going to get interpreted as parameters here, and they're being saved into the object's internal fields or internal properties. So now if we wanted to, we could add a function to this graph class. Maybe this function is going to have to do with drawing the graph. So we could say, let's create a function called draw. Now functions inside classes have a particularity. You'll notice they don't have the function keyword in front of them. If I do this, I get a mistake, right? It's like, what is this? If you're inside a class, you want to write a function, you just go and put the name of the function right away. So we have like special rules apply within the context of a template or a class. So I'm going to write a function called draw, not to be confused with our main function called draw over here, right? So this is the program's main draw function. This is going to be the graph's draw function. And I could have called this anything I wanted. I could have called it render. I could have called it display, which I often like to do to not mix up draw, but we could also call it draw. And inside this draw function, we could use the values that we've stored inside the graph object to do something. For example, we could translate the origin, right, to this particular object's x and y coordinate. Okay? And then once we're there, we could draw, we could turn off the fill. We could draw a rectangle at 0, 0 that's going to have this dot w and this dot h as dimensions. And we're going to be a little careful here. We're also going to make sure that if we translate here, remember translations, right? They take the origin point and then they move it by some amount for everything else that comes afterwards. Whenever you're doing transformations like this, it's a good idea to put a push, so this saves the origin, and put a pop to kind of put things back the way we found them, so that the rest of our code doesn't have to worry about this translated origin. The reason we're translating, by the way, is just going to make things a little easier to draw the rest of our graph, draw our lines if the 0, 0 point is actually the top left corner of our graph area. Okay, so you may notice this code does nothing, of course, because what we've done here is we've defined a function of this graph object, right, which we have over here. This is our graph object. So if we want this code to run, we need to say, hey, graph object, please run your draw code. Okay? And now we have an area being defined by this rectangle. Okay? And this happens to be, this is the position here that we are working with. If I change the parameters when I create the graph, it changes where this appears. All right. So the one concept that's important to emphasize here is that this class here is just a template. Okay, so in and of itself, it's just a series of, it's like a recipe, a series of instruction, right, that encode what it means to be a graph object in this particular program. So it means you have this constructor that will run when you first create a graph that will record 4 values as internal attributes. And then you have this one function that's what our graph can do. It can draw itself, which right now is just a box, but just use your imagination. It can draw itself. And we could have any number of instances of this graph class, right? Just to demonstrate, I could create a second graph, right? And this second graph would use the same constructor, and it would have, it could have different values here. It's not really important. This second graph now has follows the same recipe as the first one, right? It contains within it an X, a Y, a W, and a H, but these two are now completely independent from one another, other than sharing the same kind of code references. Okay? Oh, that's happened to be kind of lined up here. So you can see how these two objects, right, have their own internal values. Okay? So this gets saved over here, right? So the graph class is only a template, and we'll be able to create multiple instances. But let's just go back to having one instance here for our purposes. And let's work towards actually turning this into a real graph, which we had some working code for previously. So let's add a few more things to this constructor. The other things we're going to have is, we're going to think about what are the variables we want our graph to contain. Well, aside from these dimensions, which we added this concept, we didn't have it before, the variables for a graph really are the array, right, values and the max values we had in our previous example. So we are going to say this dot values, right? Let's create an array internal to our class called values, and max values, we're going to define it. Now we have a few options here. We could hard code it so that every graph object gets 100 values, okay? Or we could make this a parameter. We could say when we define the graph, we'll specify how many values is this graph going to allow, what the size of the history was the acceptable size. And a neat trick we can do also when we have, when this is the last variable, right, in a constructor, we can specify a default value. So let's say I'm going to make a default of, let's say 60. I just picked that number arbitrarily. So now if we don't provide a fifth parameter here, it's going to use the default value of 60 as max values, or we could override that and provide our own max values of 100, for example. So this makes our class just a little bit more flexible. All right. So what are some of the things that our graph does? Well, currently, right, remember, it's pretty basic. Aside from being able to draw itself, the other thing we want to be able to do is add values to this graph, kind of record values to be plotted. So this is the code that we had over here when we're recording some data. So let's think about, okay, in our class here, maybe we want to add a new function. Maybe we're going to call this function add new value. And this is going to give us an entry point when we're using our graph object over here to simply, just in the same way that the values array has a push function, right? We're going to create something similar here, but for our graph. So in the interest of time, I'm going to copy and paste this code so I don't have to type it again. And I'm going to uncomment this section. All right. So we can almost use this code verbatim. We just have to think a little bit about what we need to change here from what we just pasted. Now, the first thing we need to update is we cannot simply use values. Okay? In fact, just to be sure we're not going to make that mistake, I'm going to delete these variables up here because now these are all tucked inside this graph object. So I no longer need these two global variables. We're going to delete them. And so this values array now is going to always refer to the array we created to live inside our graph object. So we're going to add the prefix this dot values in front of it. And this way, each graph can have their own array called values. So if we have two graphs, you can imagine we'll end up with two arrays. And in the template, right, we don't know ahead of time how many objects we're going to be creating from that template. So we just write this in a generic kind of way. We say, just use your array, right? This object's values array. Onto that, we are going to push a number. Now, we're not going to push mouseX here. We're going to push new value. Okay, so whatever the parameter is provided, this is what we're going to record. This way, we'll be able to use a graph to record, let's say, mouseX, and another graph to record mouseY. So we're going to decide at a different point in the program what value gets added, not inside this template. Okay, this would be way too restrictive. It means every graph we would create from the template would be forced to record this mouseX value. That's not really helpful. And then we're just like we did up here. We cannot just refer to this dot value to values. We have to put the prefix this in front of it because we're talking about these two variables now, right? That are contained inside our object. The same goes for max values, and the same goes for this dot values over here. Great. Okay. So now we've created this function. So now we have the ability to say, over time, take my graph and add mouseX, for example. Right? Remember, this could be any value. So now this calls this function, right? mouseX gets passed as the parameter. This gets added onto the values array, and if the values array is too big, we remove the oldest value at index 0. And then finally, we're going to update the draw code. Right now, the draw code just draws a bounding box around the graph, but the graph is still missing. So of course, we need to go through the values we recorded and actually draw them. So again, in the interest of being lazy here, I'm going to copy and paste the original drawing code we started with, and we'll talk about how we're going to modify it to fit the new context of this class. So first, let me tweak the formatting. Okay. So the first thing we're going to do before we forget, right? Now this is no longer referring to this global variable we don't have anymore called values. Remember, it's referring to this dot values. So we are going to fix our code here. So the for loop will do the same thing it was doing before, except now it's pointing to the correct variable. This dot values. Okay. And then so that's taken care of. And now we're also going to change. So see, now we got some values appearing. Now, of course, these are going beyond the boundaries, right? Because our old code was only using the window width and height, right? 0 to width, 0 to height as its reference points. The origin has been translated over here by the graph position. So we're going to adjust these mappings to not refer to width of the window, but rather width of this graph, okay? Which could be whatever we set it to be. So this is going to be this dot w, this dot w, and then this dot h for the height of the graph. And then down here, we're going to say this dot h as well. So now our graph should be contained. Oh, not quite yet. Actually, this doesn't work because the mapping over here, right, made an assumption before. The mapping made an assumption before that the the value that we're mapping, the range of values that we're recording, in this case the mouse x coordinates, okay, went from 0 to width, okay, but I am actually exceeding this range. This is not this.w, right? This would be width over here. So this is a problem that we're going to address in the next video. So currently it means that our graph class can only really record mouse x values accurately, but this is the problem. Okay. But we'll fix that in the next video, just so not to make this video too long. So this is going to illustrate the reason why we need to know the boundaries of our data set. Okay? But for now, we can just kind of see that this is, more or less working, with the caveat that remember. So this dot values I, right, is the recorded mouse coordinates, and here I have to know what is the range of the values I'm recording in order to map it correctly, right, from 0 to h. Okay, and because in this case I know these values are mouse coordinates, okay, I can make that assumptions, but this graph could really contain any type of values in theory, so we won't be able to assume the values go from 0 to width. We're going to be smarter about this, and just hang on for that. We'll start the next video with this idea. But now this, we've encapsulated the graph idea into a class. Okay? And just to demonstrate, really quickly, we can create multiple instances again. Let's call this graph2. And how could we format this? Let's do a little bit of centering here. I'm going to put one graph on the left and one graph on the right here. So let's see. If I wanted this one to be on the left, we're going to locate it at width over 2 minus 150, maybe minus 300. Okay. And then this one will be at width over 2 plus 300. Okay, and then we're going to also draw a graph 2. Actually, not plus 300. Over there. We have to remember the xy coordinates of our graph, right, are the top left corner. So let's move this one a little bit to the left, and this one a little bit to the right, just to kind of get them separated. And let's move these down a little bit more too. Okay, doesn't really matter exactly where they're positioned for this example. So here we could add, let's say, another range of values, maybe mouseY. Okay, again, graph2, with the caveat that the mapping inside our graph class here is not working. We're going to fix that in the next video, but it's going to still do something here. So now we have a graph, right, that's mapping the left to right coordinates of my mouse, and the one on the right is mapping the up and down movements. Okay? So what this really demonstrates is now we've taken the time to say, okay, let's take this idea of a graph in our program and let's represent it as a class or a template. And we'll see that our class has a few basic ingredients, right? It will always have a constructor. So the constructor is kind of like the setup function of the class. So whenever we create a new object from the class using the keyword new up here, this constructor runs, and usually it will initialize variables, right? It will grab parameters and store them into internal variables, things like that. And then we can add any number of functions. So here I've chosen to add a function called draw and a function called add, and we just made up those names. We just wrote these from scratch. Okay. All right. And yeah, so we're going to leave it at this for this lesson. We're going to jump right into this example, and I'll better rename this. Let's call it graph. We're going to jump right back into this example for the next lesson, and we're going to start with fixing this issue here with the mapping. We'll talk about minimums, maximums, and then we'll talk also about doing some basic data manipulation in the form of calculating averages for smoothing purposes. I'll see you in the next video.